Hello, my name is Maxi. I work as a postdoc at the Department of Forest Genetics and Plant Physiology in Umeå Plant Science Center in Sweden. And today I will present with you a new resource for genomics and breeding, namely a high-density genetic linkage map for Scots pine. Scots pine is one of the two main species for forestry in Sweden, together with Norway spruce. And as we saw this morning, it has a very big and complicated genome. So what we know, thanks to the new reference genome that we have, is what we call the physical distance, which is in this x-axis, which is simply how far, in this case, two molecular markers are from one another, simply as how many nucleotides are between one and the other. But actually, the thing is that breeders, they don't really care about how far things are in a chromosome, but rather how frequently two traits or two markers or two loci are inherited together. And if you are not a hardcore geneticist, you might say, Maxi, if two things are closer on the chromosome, they for sure have a more chance to be inherited together. And if they are farther, they have a less chance of being inherited together. But the funny thing is that's only partially true. And that's where the concept of genetic distance, which has been around since the 1900s, comes about. So genetic distance actually means how likely two markers, in this case, two single nucleotide polymorphism markers, are likely to be inherited together. And as you can see, the relation between physical distance and genetic distance is not a straight line. It has parts where it's flatter, so that means that we are going forward in the chromosome, but without going forward genetically, so those are chunks that are mostly inherited together, and some other parts where the slope of the curve, which is represented by the green line, is much higher, and then that means that in a shorter area, those markers tend to be separated. So that's very important for breeders because they want to know if, for example, a trait that they want and a trait that they don't want can be separated or not. And that's what this map will be useful for. Quantitative trait loci studies, genome-wide association, and also, since we are at it, to improve the genome assembly, even though it's very good. But yeah, so this is what I wanted to present. Thank you very much.